Hey class, I know you watched the video on lesson 8. I also want to walk you through it a little bit more methodical and slow. So I've given you an example. This is also on page 54, that last example. Remember, what we're doing now is we're shortening the process of having to write out those 8 true and falses all around, and we'll shorten up the process. And we do that by just declaring that an argument is invalid. I'm saying that this is invalid. In order to make something invalid, then each premise must be true and the conclusion must be false. If it's invalid, each of my premises are true and my conclusion is false. That's what I'm declaring right here. So before you get started, go ahead and put the line under there. I would do it this way. If you having troubles, I think this would help you out. Excuse me. So put your truths in each premises right under the logical operator so that you're not confused. Because what I'm saying is this disjunction is true, this conditional is true, this negation is true, and this conclusion / symbol is true. Or excuse me, false is false. So from here, all you're going to do is work backwards or just fill in what you don't know with what you know. What I mean is this. I know that V is F. So if I find V anywhere else, it's also going to be F or false. Oh, here's a V over here. That's false. I know that negation R is T or true. So it's got to be the opposite, false. R is actually false, but when I gate it, it's true. Any more R's around here? Right there. This R is false as well. So I filled in those, and I move right here. This is a conditional if-then statement. I know that the only way an if-then statement is labeled false is when the antecedent is true and the consequent is false. And so this is already saying it's true. So I want to make sure that it is true. And so I put in there not a true, because that will make it a false. I put in here an F. Does that make sense? Conditional for the conditional. To be false, I need my ante to be true, and the consequent to be false equals false. I need to see that. It's true. So this is a false and this is a false. Because if I put true here, it would be the opposite of that. And that's what I want. That's what I don't want to do. Okay, moving on. I stayed a little bit on there a little longer than I wanted. But okay, we have the I. I is F. Any more I's? Yep, there's one right here. I know that I is an F. So I put an F here. Now I'm done with this portion. I now move into figuring out if there's any contradictions with these guys. Any contradictions. I know that if it says it's true, all right, I can check that by looking at these guys. 2 falses in a conditional always equals a true. Got it. Nothing wrong with that. Disjunction, it says it's true, but if it's a disjunction, the rule for it to be true is that there needs to be one truth statement in a symbol or proposition. But it says they're both falses. So that's a problem. This is not a truth. this is actually a false. That's a problem. So that's what we call a contradiction. And that's how you're going to label these problems. You find the one where there is a contradiction, put a box around it, and put contradiction. There might not be a contradiction, but if there is, that's how it's going to look. And if it's not a contradiction, it'll be valid. So this argument, I wanted it to say that it's invalid because I labeled it true, false. But I was wrong. There's a problem in there. So in actuality, this is a valid statement. If I find no contradictions, because think of this as a hypothesis, I'm guessing that this argument, without even having to work it out, is invalid. I'm guessing now, and once I work through it backwards, I find a contradiction. My hypothesis was wrong, therefore it's valid. But if I made this hypothesis and I found no contradictions, then I was right. It is an invalid argument. Okay, let's move over to one more. This is also in our book, and it is on page 55, the next page. It's the top scenario. A little bit easier this time. I put my line in here. I'm going to say this is invalid. I'm guessing, assuming. In order for it to make something valid, I must do what about these propositions? There's two propositions. I must label them under the logical operator as true, negation true, and I must say that this is false. If it's a negation on the conclusion side, this is the therefore, or the conclusion. If it's a negation over here, remember I put the F under the negation. True, false. Guessing. Let's move on. All right, next step. Anybody want to probably do it by yourself? Next step is to find out what I don't know with what I know. And so I know that negation F, I know that negation P is F. But so if I did not negate it, it would be true, the opposite. Any more P's over here? Right there. So I'm going to label that as true as well. I know that negation Q is T. So the opposite of that would be false. Any more Q's? Right there. I'm going to label that as false. I'm done filling that in. Now I must look and see if there's a contradiction or not a contradiction. Okay, so this is my conjunction, my if-then statement, and the only way for conditional statement to be false, is when I see the antecedent to be true, the consequent to be false. I have the antecedent true, consequent false, but yet I guessed earlier that it's true. That's a problem because it should be a false, not a true. This is a contradiction. So my assumption earlier that it was invalid, I was wrong. This is actually a valid statement. Your answers should look like this, and this, if it's a contradiction.